I think I'll leave it there. Thank you. Yes, sir.
Can you maybe explain what's the significance or why it is interesting to speak about the impact of observations in observation space?
Well, yeah. So that's, in some ways, the most direct comparison we have. So if we start off just with the measurements, then that's all we know. And when we bring the prior in, and we stay in that same space, it's how is what we've known before changed by including the model? And then you could think about the additional information you get, which is how did that information get spread to other places? But at the end of the day, the only true knowledge we have about the system itself is those measurements at those specific locations. I think that's perhaps one way to think about it.
Can you explain again your figure, like a total impact figure relative to the sample size? So actually, I didn't see the y-axis here.
Yeah, sorry, that was a small font. This one here.
And y is the total impact.
Yes, this is the total impact in those degrees of freedom units. So this is a very small ensemble here. This is like a 10-member ensemble, I believe. Excuse me, and this is 1,000 over here. So what we have is a very steep increase in the amount of information we get from the measurements. So it's the same observations for all these experiments. It's just that we're able to get more information from them by having a better estimate of the prior covariance. The better estimate means we have more robust connections between variables and space.
So in your introduction part, you introduced the Cardinali's research, and she said that only 15% of the impact is from observation.
Right.
And maybe operational centers assimilate much larger number of observations.
Right.
But in this panel, so we see the higher like impact ratio. And I thought you assimilate the smaller number of observations in this experiment.
Right.
I expected a smaller value, but why it's so large?
Well, remember, so for the ECMWF quote, it was 85% of the impact is attributable to the prior. So here we have 538 total degrees of freedom, of which we're explaining maybe 45 to 50 with the measurements. So that's a little less than 10%. So it's roughly comparable. 90% is attributable to the prior. For the European Center, it's like 85%. Yeah, so this could be normalized. It's not a ratio. No, yeah, sorry. Yeah. So but the percentage is roughly comparable. It's roughly 90% here, and it's about 85% for the weather prediction centers. But again, I think that's potentially misleading because a lot of that, what's being attributed to the prior is actually the measurements communicating their information elsewhere, which they couldn't do without the prior, but mathematically that's the way it works out. So if you don't like the observation impact or you think it needs to be done better, come up with a better method. Well, I think everyone's is all game for that. But that's, as far as I know, the way it still works at places like the European Center. And I don't know if NCEP does this sort of calculation. I don't think that I've seen it there.
Yeah, well, like EXO.
Yeah. Right.
I think in those, it's about...
That's about the forecast.
50% of the...
Yeah, I've got figures from your paper I'll show in the next presentation. But that's mainly forecast impact, right? Not analysis impact. Yeah, right. That's the next presentation. This is all about the analysis.
Yeah. And of course, the prior accumulates the information from the past.
That's right. Yeah, that's another reason why it has a lot of the degrees of freedom. Yeah. Yes, sir.
Sorry, could you briefly go over again on the interpretation of the derivative of the observations according to another set of observations?
Right, so that derivative, let's go back to that slide. This one right here, this, yeah. Okay, so we're looking at the sensitivity, the derivative with respect to the observations, right? How does the analysis respond to the observations? And the thing that we're measuring that sensitivity to is the estimate of the measurements in the analysis. So when we're all done and we have our analysis, we can go through and say, what are the observations in an analysis? They're not the same thing as the measurements. They're not the same thing as we thought they were in the prior. They're these new things. And how would that change with respect to the measurements? So it's a matrix. But the emphasis is mainly on the diagonal elements, in part because at places like the European Center, they can't get all those off-diagonal entries. It's a gigantic space, so they're looking mainly at the self-importance. We have the whole matrix. So we can look at not only the diagonal entries, but we can look at all the off-diagonal entries and metrics based upon those. And that's still a work in progress, is about all I can say about that. Did that answer your question?
Yeah. And the off-diagonal terms of that matrix, it would explain how much one observation influences the
Exactly. Exactly. Yeah. Yes, ma'am.
So, readings highly influence the data assimilation of reading. And you have to know how the vegetation treated.
I'm sorry, I can't hear you.
How vegetation treated in the Brooks model? Is there any dynamical model? Dynamical vegetation model or process-based?
Vegetation models?
Yeah.
Yeah, so there are vegetation models in the prior that we're using. So the community earth system model, I'm not an expert in the vegetation models, but they've got one of the standard vegetation models in there. But we're not using any information from that. It's simply part of the model itself. Any other questions? All right, I think that's a wrap for this lecture.